Hello and welcome to the KIM Resurrection series part 9. In this episode we'll be looking into why the keyboard doesn't work. I've measured every contact on here and they're all fine, they all feed through, there's absolutely nothing wrong with the keyboard at all. The only things that seem to work are this switch here. There we go, I managed to crash it. The switch is working fine. Go button don't do a lot. Just the store tries to do something. It's different each time. And obviously the reset is working. But none of these other keys will do anything. Well, they're all tied in with this IC just here. It's a 74145. And to do with this display driver. They're all tied in with that as well. Here we got the circuit diagram of the keyboard. That's the 74145. And we've got 4 inputs here. That's the A, B, C and D part, which comes from port B 1, 2, 3 and 4. Not port B0. This comes a little bit apparent in the code. It's offset by a bit. And then we've got these are all the outputs. It's very similar to the instruction decoder earlier. And so we've got output 0, 1, 2 and 3. Go down to the rows on the keyboard here. Why there's a row 3 I'm not sure, but anyhow, using 0, 1 and 2. And then 4, 5, 6, 7, 8 and 9 are used for strobing around the display. And that says pin 21 there. It's actually pin 2 because it's only a 16-pin chip. So this is another error on these diagram. Anyhow, we follow those 4 signals down, so one of these should come on at a time and put a signal onto each of these as you scan, and then the whole lot will be read in to port A here. So we go back and actually measure this. So I'll bring up that, and we want to, right, COM3, 8 meg, 32 channel, positive. No, we don't need trigger in here. So what we'll do is we'll just set it running and we'll just manually trigger that. Just want to grab it in the middle of its scan of all the keyboard, etc. When that's come in, there we go. We open that file. And let's see what we get. Oh, and then we'll restore the session setup, which is not quite right. Let's delete that one and delete that one. So the first row here is on the data lines, second row is on the address lines, which are now hardwired through. And then I've got a few fly leads going to these 2 rows. Now the top one is the number going into the 74145 for decoding. And did we catch the right bit? Yes, we did. So you get long pulses, a bunch of short ones and then long ones. These long ones is when it's right into the displays. There's not all here because we run out of samples. And these short ones is when it's actually scanning the keyboard. So that's row 0, 1, 2 and 3. I'm not sure why 3 is longer, but it is. And this row down here is the value it's reading back in. Now we've got 0 at the moment because we're not pressing any keys, but if we were pressing any keys and we've done this, we'll still have 0 there. I've already done this once. So it's not scanning any of them at all. But these are quite short and these are quite long. If we point the oscilloscope at this, we'll recognise this pattern. So here we've got it running. Now this is the 145, and the top 6 pins coming off here are what's feeding these transistors over here. And I'll measure them one at a time if you watch the scope. So this big pulse, see here, where are we? I lost my mouse. This pulse, that's the highest of these 4 bits that are going through this IC here. So there's input D. So that's the longest pulse. And that's one of the first ones going out. So you see the width of that pulse there. If I make this wider, see it a bit better. So we've got look at that width there. If you remember how wide that is there. And the next one over, well, that's testing on this side. These are the different display bits. So there'll be 6 of these, one for each 7-segment display. So that's the second one. The third one has come back over this side. And the fourth one is there, so you can remember exactly where that is. And the fifth one sort of joins onto the side of it. And that's the sixth one, is joined on there. Now, we've got this little gap here. That's the sixth one there. If we go back to if I leave the cursor there, mouse there, we go back to the first one. You see we've got that little gap there now. There's a little gap just here. And that must be when it's doing the keyboard. If we get a close up on the keyboard, so I'll now look at the other 4 outputs of that 145. We've got a little pulse here. See if we can zoom in on that. So it's in this gap about here. So one of the rows. There's the next one. Looks almost the same. There's a little lump just there. Third one looks very similar. And the fourth one, very similar again. So we're not getting anything going on and off. I'll press some keys. A little bit of movement, but not a lot. Oh, that was just me resetting it. So we're not getting any signals coming out. And that signal, we go back to the other display. Where are we? This one here. So we've just been measuring these 4 pins here with virtually no signal on them. Whereas these ones here, these 6, all had nice big signals on. Let's do a scan with the logic analyzer. I'll go back to that. So here's the little ones that are missing. That's where we've got the little wiggles. And then we've got the big chunks. So it all seems to fit in with that. So I'd come to the conclusion that this 74145 wasn't working properly. These 4 pins weren't working. I've ordered some and I was going to replace it. It wasn't until a bit later on, been flicking backwards and forwards through the book again, I was thinking, well, they're going to be putting zeros on there. How are you going to measure that if there's nothing on here? And then I stumbled across a bit that said that there's pull-up resistors built into the RRIOT chip. I'd missed that bit before. And then thinking back, we go back to this part, the address decoder. You got these 4 resistors sitting here. And what are they doing? They're pulling up K0, K5, K6 and K7 to the positive rail. So when this isn't switching, it's pulling them up. These other ones are just not used. These other ones here. So I think we just need pull-up resistors. So it's the same IC. So these are just getting pulled up and down. So you've got like a supply here. It'll come round through here. And this will either pull that down to 0, seeing as they're PMPs, not NPNs. And there'll be, when this goes to 0, this voltage will go low and this will switch on and conduct through. So we're putting the supply down and then we're switching these to the low here to switch the current down to turn them on and off. So there's your pull up for them, and these are relying on these here. So when you press a key, you'd have a pull up here, 5 volts on this bit, which will come through to here, through the key, then back up through there. And this bit, if it's switched on, will pull that down, pull this to 0. So normally when reading this port here, it'd all be 1s, unless a key was pressed, and then one of them would be a 0. So I'll need to reprogram my cloned PIO chip, or RRIOT chip, to put pull-up resistors in. Let's see if that works. This is a data sheet for the microcontroller. Here we have the pull-up part, so I've got to find CNPUB, because I'm port B, and turn all these pull-ups on. So if we go to the actual code, and do that right at the beginning when it loads up. So here's all the actual KIM-1 ROM code. I made this so I can put another one in there and run test code if ever I need to. I left that blank, so right, where are we? We'll do that right at the beginning where we configure everything. There's a clocks, IO. There we go, where we're setting up the ports. And we'll do that right here. So that's port B, and we'll be doing, so we do set M, a bit, I believe. Yep, because that's what we do there. That will just turn them all on. So, yeah. Port B, port up, on. And we'll save that. Now what we got to do is compile it and program it. I'll turn this off now. Set all off. There we go, that's nice and easy to unplug. There's the code done. Let's just program this. We'll get in there. And now we want to, let's build that again. I don't trust that. Build OK. And program the device. It's on the other screen. Right, there we go. That's that programmed. Now we'll pop it back in. Alright, let's turn it on, see what we get. Still nothing. Let's go back to the analyzer, see what that can do. Let's just trigger it. And reload. Here we go. And we've got in 7s instead of 0s, which means we've done something. That's right. That's correct. It's not reading the first. We're not reading the first 7 bits of the keyboard. We're just only reading the bottom 4. So if we now press a key when we trigger, we hold the number 6 key down this time, and we do our trigger. So row 0, and we're just reading the bottom 4, so we should have a number 6. See what we got. So reload it again. Well, there we go. Ah, there we go. We've got number 6. Let's try that again on another one. Actually getting somewhere. We scan again. Which one go for this time? Let's go for a 5. The 5 key. And reset again because it crashed again. And 5. Just wait for the data. And reload. There we go. And we got a 5. So we've now got it semi-stable running, and the keyboard's giving signals out. I think we'll leave that there, and we'll continue this in the next episode. So don't forget to like and subscribe, and hopefully I'll see you in part 10.